Bismillah ar-Rahman ar-Rahim. What I will try to do in this video, I want to make a review about finding the limits at infinity. In the previous video, we explained what's the sequence and how to deal with the terms of the sequence in general, and how to find the limits at infinity, as n goes to infinity. What will happen to the sequence? The sequence will converge or diverge. So I said myself, why not I will do like a review about finding the limits at infinity, which was done in Math 101, in Calculus 1. So just this is an intuitive definition. What's the meaning of a limit at infinity? Means as x goes to infinity, as the values goes to infinity, this x goes to infinity, the function is going where? Like in this case, the function is going to L, limit as it goes to infinity is equal to L. Well, this is L, y equal L. The same thing here. And sometimes it can cross it, but still at the end it will go around it. And the same thing if we say x goes to minus infinity, it's the same idea. But now I'm going to minus infinity instead of going to plus infinity. Okay. Now I will try to explain that through different functions. Try to deal with different functions. I hope I can explain it in this small video. Constant function. What do you mean by constant function? This is a constant function. Assume I have f of x equal k, or this is k. Let me. This is k. Assume this is k. So as this goes to infinity, the function is going to where? To k. So the limit as it goes to infinity, it will be k. Also, the limit as it goes to minus infinity. A function k, constant function, it will be k. Okay, now we'll go to the polynomials. What will happen to the polynomials? What will happen if I take x to the power n as a common factor, then I have an plus this. Whereas x goes to plus or minus infinity, all of these are going to 0. So actually, the limit of all of this is the same as the limit of this one. And that depends on an and also the going to infinity or minus infinity. It will go either to plus or minus infinity. So if I have limit x cubed, for example, then what will happen? It will be infinity cube, infinity times infinity times infinity, that will be infinity. However, if I have minus infinity, that will be minus infinity times minus infinity times minus infinity. And that will be equal to minus infinity. What about if I have the limit x goes to infinity or minus infinity? Let me see. Minus infinity of 3x cubed plus 2x squared minus x plus 10. What will happen? This limit is the same as this limit of 3x cubed. And so the control is in the one with the upper, with the highest degree. Okay, highest power. So that will be what? 3 times minus infinity times minus infinity times minus infinity. That will be minus infinity. Okay, this is for the polynomials. Now for the rational function, the same idea. The limit of function or polynomial over polynomial, it will be controlled by this. So if the degree of the numerator is less than the degree of the denominator, then that will be what? That will be 0. Okay. If the degree are equal, then it will be خلاص cancelled. So it will be n over bm. If n greater than m, then what will happen? Then it's either plus or minus infinity. It depends on the going to infinity or minus infinity. Also, it depends on these coefficients. Okay. As an example, if I have c over x to the power r, what will be the limit? Yeah. So the degree is less, this degree 1, this degree 0, and this is degree r. where r is a positive, so r is greater than 0. So degree is, so the answer is 0. And the same thing going to minus infinity. Now we'll go to the exponential function. What will happen to the exponential function? This is the graph for the exponential function. This is the graph for exponential function, e to the power x, 2 to the power x, 10 to the power x. All of these exponential function, a to the power x, where a is greater than 1. So if you think about it, this is goes to what? As x goes to minus infinity of e to the power x, that go to 0. But as x goes to infinity, limit is goes to infinity of e to the power x, that will be infinity. Okay, because it goes to infinity, the function is going where? Going to infinity. Okay. Now if I go back to e minus x, the graph will do something like this. So as x goes to as x goes to plus infinity, the function is going to 0. As x goes to minus infinity, the function is going to what? To infinity. Minus infinity and going to infinity. Okay. Tan inverse. I'm trying to do different functions. Tan inverse. This is, I know this is pi over 2, and this is, if you remember the graph, minus pi over 2, and the function is doing something like this. So as it goes to infinity, I'm getting what? Pi over 2. Minus infinity, minus pi over 2 for tan inverse of x. So just to remind you about some of the known functions. Okay. Now if we want to do this, yeah, limit, it goes to infinity, x squared minus x. Is it? Yeah. So what is the control? The control with this one, with the highest power. That will be x squared, and that will be infinity times infinity, which is infinity. Okay, trig functions. The problem with the trig function either goes to infinity or minus or plus infinity, the same idea. Sin x or cosine x, it's the same idea. Why the limit does not exist? Because if you remember, this is the sine function, and it will continue doing this. Now, as I'm going to infinity, I don't know where I will stop. The numbers will oscillate between -1 and 1, but I don't know which specific number will go to that. So the limit does not exist. The root function, there is a strategy to deal with the root functions, which is I will try to get rid of or to make the root in a way easy to deal with. Now, if I apply the limit, I have infinity over infinity, and we'll do L'Hopital's rule. That means I cannot do the calculation this way, so I need to do something. I need to rewrite the function in a different way. One way to do it, if you remember, square root 2x squared plus 1. This is if I take x squared common factor, that will be 2 plus 1 over x squared. And that gives me the square root of x squared, square root 2 plus 1 over x squared. And this one is absolute value of x. Here's the catch. Now what I will do, I will write the numerator in this way, which is just calculation. Absolute value of x, square root 2 plus 1 over x squared over. Also, we'll do the same here. I take x common factor. I have 5 minus 3 over x. Now be careful. As x goes to infinity, absolute value of x will be what? X is for sure is positive, so that will be x. As x goes to minus infinity, absolute value of x goes to where? To minus x, since x will be positive, since x will be negative in this case. Now I just continue. This will be x. So that means what? I can cancel this with this. Now I can apply the limit. If you apply the limit, this goes to 0. Have 1 over infinity, which is 0, and this is also goes to 0. So I have square root 2 over 5. Now, if we do the same for the second one, I need to be careful. Why? Because this one will be the limit. X goes to minus infinity. The same thing, absolute value of x, 2 plus 1 over x squared over x, 5 minus 3 over x. Yeah, but be careful in this case. Because this one will be what? Absolute value of x equal to what? In this case, equal minus x. So this one will be limit x goes to minus infinity of minus x square root 2 plus 1 over x squared over x, 5 minus 3 over x. So I cancel x with x. I'm getting what in this case? Minus square root 2 over 5. Yeah. Okay. Different question now. I'll do this as it goes to infinity. So what will happen? Let me do it in the next page. X goes to infinity. Square root x squared plus 4 minus x. Is it? Plus 1. Sorry. Minus x. If you apply it, you have infinity minus infinity, which is indeterminate form, which we'll explain when we deal with the L'Hopital's rule. So what I will do in this case, I need to rationalize. This is make it over 1. Rationalize. Okay, that give me what? Limit x goes to infinity. That give me x squared plus 1 minus x squared. In the numerator, in the denominator, I have x squared plus 1 plus x. So that will be limit x goes to infinity. 1 over this. Now, if you apply the limit, you have what? 1 over infinity, because infinity squared is infinity plus 1, and all this infinity plus infinity. I'm getting 1 over infinity, and that will be 0. That will be 0. Now, let me do the second one, which is a little bit interesting. Square root x squared plus 4x minus x over. No, nothing. That's it. This is my question. So what I will do, the first step, I have infinity minus infinity. So first step, I need to rationalize. So this is make it over 1 and multiply by the conjugate. Yeah. So that I can deal with the square root. That will be what? Limit x goes to infinity of what? X squared plus 4x minus x squared over this. So this is cancelled. So if you apply it, you have infinity over infinity, which is still, you cannot substitute. So I need L'Hopital's. So it will be a problem like the first two problems, where I need to take, yeah, x as a common factor. Easier, maybe. Yeah, because the numerator already times x. So this one, I'll take x as a common factor, so I have a square root. X squared, I have 1 plus 4 over x plus x. Okay. So this x squared, I can take it out as absolute value. That will be 4x over absolute value of x. I'm trying to do that in details. So I hope that you remember what we did before in Math 101. Okay, limit x goes to infinity. 4x over what? This is x. Since x goes to infinity, so the absolute value will be x only. Plus x. Now I can take x common factor. In the denominator, you have what? X square root 1 plus 4 over x plus 1. X cancelled. Now I can apply the limit. You have what? 1 square root 1 plus 0 plus 1. So you have 1 over 2. I hope it's clear. Now let us deal with Lobiter's rule. What do you mean by Lobiter's rule? If you have functions that are differentiable in the open interval concerning C, G prime not equal to 0 for all x in this AB except possibly at C itself. If I have 0 over 0 or infinity over infinity, then what will happen? The limit of the function, the limit f of x over g of x, as this goes to C, is the same as the limit of the derivative of the numerator over the derivative of the denominator. I'm not doing quotient rule, just the derivative of the numerator or derivative of the denominator. I say it's correct if it is infinity over infinity minus infinity over infinity, infinity minus infinity, which is the category infinity over infinity. Okay. Now, need to verify the conditions first. You need to be sure that I have 0 over 0 and infinity over infinity. Otherwise, it will make a problem to us. Okay. Where we get the wrong conclusion. So first, I need to check it's 0 over 0 or infinity over infinity. Then I will do a little bit of one-sided limit or goes to infinity is the same. You can do the same. Differentiate the top alone and the bottom alone. You can do it more than one time. And this is sometimes does not work with some problem. Like this one, it will, yeah, it oscillates. It will go the square root. Yeah, you will not reach a conclusion. Okay. So this is one form, which is 0 over 0, infinity over infinity. The other form, it's 0 times infinity. If you have 0, this is still undetermined product. What you will do in this case, you have a function times a function. When one is going to 0, the other one goes to infinity. What you will do, you try to write this one in a form where I have either 0 over 0 or infinity over infinity. So either I will take g, make it in the denominator, 1 over g, or I take f, or I can make it g of x over 1 over f of x. Yeah, do it the way you like. Usually try to do it in a way so that when you differentiate, you can reach the answer quickly. The same thing if you have infinity minus infinity, like in this case, you have one is infinity, the other one is you have infinity minus infinity. You need to rewrite it in a way that infinity over infinity or 0 over 0. If you have these powers, function to the power function, f of x to the power g of x. So you have 0 over 0, or infinity to the power 0, or 1 to the power infinity. One of these three, what you will do, and instead of dealing with y, f of x over g of x, you will deal with ln y, which is g of x ln f of x. You will find the limit as goes to infinity, for example, as x goes to a or infinity, it's up to you. Yeah. Which is the limit of this. You notice in all of these three cases, this limit will be 0 times infinity. So try to solve it, you get a value L. This L is not the limit of this one, it's the limit of ln y. So what will be the limit of y as this goes to a? It will be e to the power L. And that will be your answer. Okay. Now we'll come back to the sequence. Why I'm dealing with this limit? Because this theorem, to find the limit of a sequence, you can find what? You can consider the sequence as a function of n. You can define f of n as the sequence, and then find the limit of f of x as this goes to infinity. If that limit, I'm getting L, then the limit of the sequence is equal to L. Let me do this example, which is the easiest one, I think. What I will do, instead of writing the limit, I will say f of n equal an equal 1 over n, where what is f of x? 1 over x. And what is the limit as this goes to infinity of 1 over x? That will be 0. I know it. So that means the limit of 1 over n as n goes to infinity will be the same thing, which is 0. And the same thing with this one. So my f of n will be an 1 over 2 to the power n, where is, what is the f of x in this case? 1 over 2 to the power x. Note the limit as this goes to infinity, 1 over 2 to the power x, it will be what? 1 over 2 to the power infinity is infinity. So 1 over infinity, that will be 0. So the limit 1 over 2 to the power n as n goes to infinity will be 0. The same thing with this one. I think this one is easier. Yeah, let me start with this one. So what is my f of n? Is an, which is n over n plus 1, where f of x is what? Is x over x plus 1. So what is the limit of f of x as this goes to infinity? Oops. As this goes to infinity, that will be the limit as this goes to infinity of x over x plus 1. I'm doing it in details. This is which category? Which is, this one is the rational polynomial, rational functions. I have function over function, same degree. So I deal with the leading coefficient, which is 1 over 1. So that will be 1. So that implies the limit as n goes to infinity of an, which is the limit as n goes to infinity, n over n plus 1, that will be 1. This one, what is f of n? F of n, which is an, which is n over 1 minus 2n, where f of x, it will be what? Yeah, I'm doing it in details, but just I hope that you will understand. So what is the limit f of x as this goes to infinity? It will be x limit x goes to infinity, x 1 over 2x, same degree. So that will be minus half. So that means the limit of an that will be minus half. By the way, all of these limit laws which we did before, it will work. So the limit of the sum is the sum of the limit of the difference of the limits, constant, take it out, product, quotient, be provided in the denominator equal to 0, power, you can take it inside. Actually, if you have a continuous function, you can take the limit inside. Squeeze theorem, like what we did before. So we can squeeze the sequence, Bn between two sequences, an and Cn, where the limit of an and Cn is equal to L, then the limit of the one in the middle will be L. If you have the limit of absolute value of a sequence is equal to 0, then the limit of the original sequence is equal to 0. And we'll explain that. When a sequence can fail to have a limit, usually there are two cases. If the limit if the terms increase without bound, they're going to infinity. Or decrease without bound, they're going to minus infinity. And for example, if you look at this one, as you're applying the limit as n goes to infinity of this, that will be what? Infinity minus 3, which is infinity, square root of infinity, which is infinity. So the limit, we say, diverges. The sequence diverges. We say that fail to have a limit, or we say diverge. In the previous ones, we say converges. Okay. Also, when the terms are alternate between values. And for example, minus 1 to the power n is a very clear case, because this one, if we look at the terms, assume starting from 1 n equal 1 to infinity. Like this. So n equal 1, I have minus 1. N equal 2, I have 1, minus 1, 1, and so on. Where I will stop, I don't know. So we say the sequence diverges. The sequence an, we say the sequence, which is an diverges. Because I don't know it will stop where. The same thing if you look at this one. Assume I'm starting from 1. At 1, it will be 3 minus 1, that will be 2. At 2, it will be minus 1 squared, that is 1, 4. At 3, it will go to 2, 4. I don't know it will stop. So we say the sequence, which is 3 plus minus 1 to the power n, diverges. Is it only alternate between 2 values? No, sometimes by more. For example, this one, I have cosine pi over 6. I have over 3. Then I have cosine pi over 3 at n equal to and so on. I don't know where it's similar to this one. I don't know where they will stop. Okay. Okay. Now let me go back to this minus 1 to the power n times an. Is it always diverges? No. Why? Because it depends. If the limit of an goes to 0, then I have, yes, this is goes to minus 1 or 1. But if it is times 0, then the result is 0. But if this is not 0 or goes to infinity, then I have the problem. They will oscillate. It will alternate between 2 values. So if I have this one, for example, then I take an. An is what? 1 over n. So what is the limit of an as n goes to infinity? This is 0. So the limit of this, still it's minus 1 over n. That will be 1 or minus 1 over infinity. For sure, it will be 0. So the answer is 0. Okay. This one, what is an? N over n plus 1. What is the limit of an as n goes to infinity? Of an of n over n plus 1. That is what? 1, not equal to 0. So this limit does not exist. And we say the sequence diverges. Because now we are in this case where I have the limit of the sequence without minus 1 to the power n is not equal to 0. This one, you have what? Yeah, I have an n plus 1 over 3 to the power n. What is the limit as n goes to infinity of n plus 1 over 3 to the power n? If you apply just the rule, you have infinity over infinity. So do Lipper's rule here. So I get what? Limit n goes to infinity. 1, what is the derivative of this? Now consider the function. Now consider the function x plus 1 over 3 to the power x. So it will be f prime. What will be limit x goes to infinity of f of x? That will be limit x goes to infinity x plus 1 over 3 to the power x. Now I have infinity over infinity. Lewis rule. So that will be limit x goes to infinity of what? Yeah, that will be what? 1, 3 to the power x ln 3. Now I have 1 over 3 to the power infinity, which is 0. So this limit will be equal to, this is L, will be equal to 0. So the sequence converges to 0. From there, I'm getting this. Okay. What about this 2n? which is the even numbers, huh? These are the even numbers. Here is the even numbers 2, 4, 6, 8, blah, blah, blah. Huh? What is the limit of an as n goes to infinity? Yeah, very clearly have 2 times infinity, so it's infinity, so diverges. What about this, the odd numbers? If n equal 1, I have 1, n equal 2, 3, 5, 7. These are the odd numbers. So what is the limit of this to n minus 1? It's 2 times infinity minus 1. For sure, it's infinity. Diverges. What about this one? Yeah. Yeah, so for sure, this one will go to where? As n goes to infinity. It will diverge. Yeah, how to explain it? You have what D1, I'll try to do it, equal 25. D2 will be 20. D3 will be 15. Yeah. Then 10, 5, 0, minus 5, minus 10, blah, blah, blah. It will go down more and more. So it will diverge. It will not, it will decrease. It will decrease without bound. Very clear. Decreases without bound. There is another way to check, especially these sequences defined by a recursive definition. You can do it this way. Assume the sequence converges. That means what? The limit converges to a value L. Converges to L. Another way, huh? This is step method 1, method 2. Assume this sequence converges to L. That means the limit of an as n goes to infinity should equal to L. And what is the limit? D. He's using D, not A, D. What will be the limit of dn plus 1? For sure, it will go to infinity. It will go to the same L. It should converge to the same value. If that is the case, and I have since dn plus 1 equal dn minus 5, then that implies the limit as n goes to infinity of dn plus 1 equal the limit as n goes to infinity of dn minus 5. And that means what? L equal L minus 5, which is impossible. So this assumption is wrong. So the sequence diverges, cannot converge. Another way to do it. Yeah, this sequence n over square root 10 plus n. So I have what? I need to find the limit of this sequence as n goes to infinity of an. That will be the limit n goes to infinity, n over square root 10 plus n. Okay. That give me what? Yeah. I have infinity over infinity. I can use L'Hopital's rule, see what will happen. If I use L'Hopital, I have infinity over infinity. So I'll deal it with, usually if I have L'Hopital, I need to deal with the function. So I have the function is x over 10 plus x. So that means the limit as x goes to infinity of this, I have infinity over infinity. So that use the L'Hopital's rule, what you will get? You will get 1 over what? Here I have 1 over 2 square root 10 plus x. That will be what? Limit as it goes to infinity. 2 square root 10 plus x, which is infinity. So the sequence is a divergent sequence. Divergent sequence, or the sequence diverges. Okay. 2n over square root 10 n square plus 1. This is from the book. So I need to find the limit of an as n goes to infinity of 2n. Yeah. I can deal with the function or I can deal with it completely directly. That will be limit n goes to infinity. I have 2n. Here I can take n as a common factor. So I have 1 in the square as a common factor. That will be 1 plus 1 over n square. That gives me the limit as n goes to infinity. They will explain it for the this will be absolute value of n for the root. This is equal to n, so this is cancelled with this. So I have 2 over root 1 plus 0, so I have 2. So the limit is equal to 2. This one, yeah, be careful here. Now, yeah, limit of an as n goes to infinity, that will be limit n goes to infinity cosine 2 over n. Yeah. How to do that? Yeah, as n goes to infinity, I have what? 2 over infinity. That will be cosine 0, which is 1. Since cosine is a continuous function, I can take the limit inside. Yeah, so I can deal with, actually explain that later, but it's okay. Since we know it, that will be cosine, since cosine is a continuous function. That will be cosine. This is 0, but this is 1. Okay. Limit ln n over n. Okay. What I will do, yeah, it will be infinity over infinity. So I take f of x as ln x over x. I need to find the limit of f of x. What's this? As x goes to infinity of ln x over x. I have infinity over infinity. So I use the Lipper's rule. You'll get what? 1 over x over 1. And that will be 0. So this limit is equal to 0. This one, yeah, I take f of x as x to the power p over e to the power x. I need to find the limit of an as n, which is limit n goes to infinity n to the power p over e to the power x. Okay. Yeah, I need to be careful here. So I need to find the limit. That give me what? Limit x to the power p over e to the power x as it goes to infinity. This is, I have infinity over infinity since p is positive, so I have for sure infinity over infinity. What I will do, differentiate. I have p x to the power p minus 1 over e to the power x. I still am having infinity over infinity. Do it again. I have limit x goes to infinity, p times p minus 1 x to the power p minus 2 over e to the power x. If I do this p times, I'm getting what? Limit x goes to infinity. The denominator will be e to the power x. It will not make a difference. This one will be p minus 1, p minus 2, p minus 3, until I reach 1. That's it, and x will disappear. So I have what? I have a number that will be limit x goes to infinity of p factorial, or a number, who cares? A number over infinity, that will be 0. Number over infinity, that will be 0. So this limit is equal to 0. Which is clear. I will do it again and again until I get rid of x. So if I have x squared, next time I have x, then I have 1. That's it. So that gives me a number over e to the power infinity, which is infinity. So a number over infinity, for sure it will be 0. A big number, who cares? Huh? Over infinity, for sure it will be 0. N squared over 2 to the power n minus 1. Yeah, it's a little bit complicated. Let us do it. I need to find the limit as n goes to infinity of an, which is the limit n goes to infinity of n square over 2 to the power n minus 1. I'll take f of x as x square over 2 to the power x minus 1. I need to find the limit as x goes to infinity of this function. I have infinity over infinity. I'll do Lewis rule. It will be 2x over 2 to the power x ln 2. Still, I have infinity over infinity. Do it again. I have infinity over infinity. That will be 2 over 2 to the power x ln 2 square. Now, below infinity, I have 2 over infinity, which is 0. So this limit is 0. So it converges to 0. Sequence converges to 0. Find the limit of this sequence whose n term is this. Okay, whose n term is this. Okay. Yeah. I have function to the power function now. Okay. Yeah. Okay, so how to do this? I need to find the limit as n goes to infinity of an, which is the limit as n goes to infinity of this function. So I'll take it with f of x as 1 plus 1 over x to the power x, which is 1 to the power infinity. If I do limit x goes to infinity, I have 1 plus 1 over x to the power infinity, 1 to the power in undetermined form. So what I will do, make this y. I'll find ln y. Ln y will be x, ln 1 plus 1 over x. So I'll try to find the limit of ln y. That will be the limit as this goes to infinity of what? X ln 1 plus 1 over x. If you do that, you have infinity times 0. So what I will do, I'll take x to the denominator. I have 0 times infinity or infinity times 0. So I have ln 1 plus 1 over x over 1 over x. Okay, now I have 0 over 0. Apply L'Hopital's rule. Now it's ready. Limit x goes to infinity. That will be what? Be careful here. 1 over 1 plus 1 over x times derivative of this, which is minus 1 over x squared. All of this minus 1 over x squared. This is cancelled. Apply the limit. I'm getting 1. Is this the limit of y? No, this is the limit of ln y. So what will be the limit of y? That will be e to the power 1, which is e. So this limit is equal to e. So the sequence converges. So we say the sequence converges to e. Sine n over n, or sine 2n, or n sine 1 over n. Okay. Yeah, be careful. Sometimes we need the squeeze theorem. In this case, I think we need the squeeze theorem. Why? I know sine n is between minus 1 and 1. So that implies sine n over n is between minus 1 over n, 1 over n. I call this an, and this is bn, and this is cn. So I have the limit of a as n goes to infinity of an, that will be the limit minus 1 over n, which is 0. The limit as n goes to infinity of cn, that will be the limit as n goes to infinity of 1 over n. That will be always 0, also 0. If you remember the squeeze theorem, here I have the squeeze theorem. Squeeze the sequence bn between two sequences. Well, the limit of these two sequences is the same. Then the limit of that sequence in the middle should be the same. That implies, yeah, that implies the limit of n goes to infinity of bn, which is the limit as n goes to infinity of sine n over n, that will be 0. The same thing here, same idea. cosine 2n is between -1 and 1. So cosine 2n over 3 to the power n. Then talking positive numbers, that will be always positive, huh? So the same thing, we call this an, we call this bn, we call this bn, and we call this cn. I have the limit as n goes to infinity of an is equal to 0. Bn, oops, that implies the limit as n goes to infinity of bn, which is the limit as n goes to infinity of cosine 2n over 3 to the power n. That should be the same, which is 0. Is it the same if I have select functions I need squeeze theorem? No. Like in this case, I need to find the limit as n goes to infinity of n sine 1 over n. Yeah. This will be infinity times something, I don't know. So let me deal with it as a function. I have f of x sine 1 over x. I want to find the limit as this goes to infinity of x sine 1 over x. I will do this trick. I let t equal 1 over x. Then I change everything in terms of t. That will be limit. This is 1 over t. If t equal 1 over x, that means x is 1 over t. That will be sine t. Now, if x goes to infinity, then t goes to what? Goes to 0. If x goes to infinity, I have 1 over infinity, then t goes to 0. And this is, I know it. What is the limit as t goes to 0 of sine t over t? This is 1. So my answer here is 1. Yeah. Now, the thing as I said before, we can work it out with the limit. If the limit is equal to L of a sequence and the function is continuous, I can take the limit inside. So the limit of f of a n equal f of L. The same thing, this is what will happen here. That I can write it limit, no, not limit. Since sine is a continuous function, this is continuous, then that will be sine of the limit as n goes to infinity of pi over n. And that will be what is this one? That will be sine 0, which is 0. By the way, this is the way which I did here. In which one? I think there is one with cosine somehow. Yeah, which is, I forget. There is one with cosine. Yeah, this one, cosine 2 over n. This is what I did since cosine is a continuous function. I took it outside. This is continuous function. Continuous function. Okay. More interesting, this one tan is continuous in its domain. So I can take the limit inside. That will be tan limit n goes to infinity of 2n pi over 1 plus n pi over 8n. Now I have same degree. This will be the same degree. So that will be tan. What's the limit of this? Same degree, just a coefficient, 2 over 8. This is, I think, tan inverse, should we? Or tan, yeah, there is a pi. Forget the pi. That will be 2 pi, sorry. It's 2 pi over 8. So that will be tan pi over 4, which is 1. Okay. Len, you want to deal with Len? Yeah, you can deal with this trick. This one I can say limit x goes to minus infinity. Of what? Of Len. I know Len, the difference is Len y, Len x, Len A minus ln B, ln A minus ln B, it is ln A over B. So that will be ln 2 plus x squared over 1 plus 2x squared. Now, since the ln is a continuous function, I can take the limit inside. That will be ln limit x goes to minus infinity of this. Yeah, I'm dealing with x because I brought this question from, but you can deal with it also if you have a sequence, the same idea. But I don't have x goes to minus infinity, x should go to infinity, but it's the same idea. Now, what will happen here? I have ln, this is same degree, so I have ln of 2, half, ln of half. This limit is what? Same degree. So the leading coefficient. This one, I can take the limit inside. That will be tan inverse with this limit. Now, to do this limit, I need the trick of taking common factor to get rid of this absolute value. So I take limit x goes to minus infinity, square root. This one I can take x to the power 6 common factor. You have what? 1 over x to the power 6 plus 4 over, I have x cubed common factor, 1 over x cubed minus 2. And that give me what? Yeah. That will be equal to what? Tan inverse of the limit as x goes to minus infinity. What is this? X to the power 6, take it outside. That will be absolute value x cubed. Okay. This one is what? Since x goes to minus infinity, that will be minus x cubed. So cancel x cubed with x cubed. Now take the limit. That will be tan inverse of what? Minus 2 over minus 2. It's minus root of 4 is 2 over minus. That will be tan inverse of 1. And that is pi over 4. Yeah, I hope the idea is clear. This one is a little bit tricky. I need to find the limit as this goes to infinity. Let me do it with x equal infinity. X equal minus infinity. Yeah. Have what? X minus ln 3 to the power x plus 1. That is what? Limit as x goes to infinity. You have what? X, I can make it ln e to the power x. That's the trick. That will be limit. Now it will be similar to this one now. I have what? Ln ex over 3 ex plus 1. Can take the limit inside. That equal ln of the limit x goes to infinity. Yeah, e to the power x over 3 e to the power x plus 1. Now this limit, cannot do it easily. At least I can do what I can take. That would be then limit x goes to infinity. I have e to the power x here. Down I can take e to the power x common factor. I have 3 plus e minus x. This is cancelled. Now, as this goes to infinity, this goes to 0. So I have ln of what? 1 over 3. Yeah, that will be the answer. Now, for r to the power n, Yeah, I have this case for r to the power n. Yeah, r to the power n, what will happen? Yeah, I have this actually. I explained it in the previous video, but I mean, let me rewrite it. Rewrite all the cases for this in one place. Now, if r is less than or equal to -1, what will happen to the sequence? It will diverges. If r is between -1, that will be 0. If r equal 1, that will be 1. If r is greater than 1, that will be diverges. I think this will explain it all the cases. He said these are the only converges cases. I included the diverges cases also in one place. So what I will do to check that, just I check r. I have a n r to the power n. So what is my r? R equal -half, which is less than 1. So I am in which case? I am in this case. So it will be the limit 0. That's it. Now it comes to this. E is what? Greater than 1. E is greater than 1. E is 2.7 something. Who cares? Now this will be greater than 1. So I am in which case? I am in this case. So it will diverge. Now these are from the book. Limit n goes to infinity of a to the power n. Let me rewrite it in this way. E over 4 to the power n. Yeah, so I need to check this number. E over 4. Which case? This will be less than 1. This is 2.7 over 4. That will be less than 1. So I'm in this case. So this limit is equal to 0. This one, I have a limit n goes to infinity of an. Let me rewrite it. Limit as n goes to infinity of minus. This is 3 to the power -1, which is 1 over 3 to the power n. Yeah. This one is what? 3 to the power minus n with the minus sign. So it's -1 over 3. This one is less than 1. I have 1 over 3, it's still less than 1. So I am in this case. Answer is -0, which is 0. Yeah, sometimes I'll ask you to find the formula and then find the sequence converge or diverge. This one, I think we did it, and this was the formula for it. So, yeah, we did it before, where I have 5, this is 5 squared, this is 5 cubed. So I have 5 to the power n, and this 3, 4 with the minus sign. I have starting from 1, n equal 1. Assume starting from 1. Then I think we did this. So now we need to check the limit of an, where n goes to infinity. And I know an is this one, -1 to the power n minus 1, n plus 2 over 5 to the power n. You remember we said if we have something like this, how to do it? Yeah, just I check the limit of an, forget about -1 to the power. If it is 0, then the limit is 0. If the limit is not 0 or infinity or minus infinity, then we say diverges. Then the limit we say does not exist. Okay, so check this. I need to find the limit as n goes to infinity of n plus 5 to the power n. Take it as f of x. I need Robinster's rule for that. So the limit, or I can do it right away. I have infinity over infinity. So I'll do Robinster's rule. That will be 1 over 5 to the power x ln 5, and that will be 0. So this limit is equal to 0. So it converges to 0. These are the questions for the finding the n term. I put all the questions in the book. Yeah, I think they are easy ones. Okay, 45. Then also I find the limit. Converges or diverges. I find the n term and then find the limits. 2, 4, 14, 20. It's very clear. This is what, 2 plus 6. This is what, 2 plus 12. This is 2 plus 18. This is 6 times 3, huh? This is 6 times 2. So for sure, my AN is what? As n equal 1, starting from 1, huh? I'm starting with it with n equal 1. Starting with n equal 1. So at n equal 1, AN is what? I need to write it what? Minus 4 plus 6n. Yeah, so at n equal 1, it will be minus 4, which is 2. At n equal 2, at n, just to check, at n equal 2 minus 4 plus 12, which is 8. And that's it. Yeah. That's minus 4 plus 6. And what is the limit of AN as n goes to infinity of this sequence? For sure, it will increase without bound, so it's infinity. Okay. So it diverges. Yeah. 46. Yeah, what is this? This is 1 over 1 factorial. This is 1 over 2 factorial. 1 over 3 factorial. 1 over 4 factorial. Yeah, 24 times 5, that will be 1 over 5 factorial, and so on. So this is my n will be 1 over n factorial. And what is the limit of an as n goes to infinity? Is for sure infinity factorial is infinity. So it's 1 over infinity, which is 0. Yeah. 47. What will be 47? Yeah. How to check it? At n equal 1, I have a1 minus 2, a2 equal 1, a3 equals 6, a4 equal 13. Yeah. A5 is 22. That will be what? Minus 2. I can write it as 1 square minus 3. And this is 2 square minus 3. This is 3 square minus 3, correct? Yeah. And this is 4 square, which is 16 minus 3. This is 5 square minus 3. So my AN is n square minus 3. And what is the limit of AN as n goes to infinity? That will be for sure infinity. 48. What will be that? I think this one is easy. I have what? A1 equal 1, A2 minus 1 over 4, which is minus 1 over 2 square. A3 is 1 over 9, which is 1 over 3 square. A4 minus 1 over 16, which is minus 1 over 4 square. So what is my AN? Will be minus 1 to the power n plus 1 over n square. This one I can write it as 1 over 1 square. Yeah. So when n is odd, it's positive. When n is even, it's negative. Yeah. So what is the limit of AN as n goes to infinity? I need to check the limit without. So that will be 0, since the limit as 1 over n square, that will be 0. Okay. This one, 49. I think it's very clear. I have 2, 3, 4, 5. So my an will be what? Starting from n equal 1, so that will be n plus 1 over n plus 2. Yeah. Yeah. And what is that? What is the limit here? Yeah, the limit of an as n goes to infinity. That will be same degree. So that will be 1. Yeah, this one is just a joke. I don't know how to see it. But this is an will be 2n factorial. Yeah. Well, this is 2 factorial. This one is 4 factorial. This one is 8 factorial. 6 factorial, sorry. It's 120 times 6, so 720. And now the rest is like that. And for sure, the limit of this one, as it goes to infinity, will be infinity for sure. 51. What will be that? Yeah, a1 equal 2, which I can write it 1 plus 1. a2, 1 plus half. a3 is 1 plus 1 over 3. I'm sure an will be 1 plus 1 over n, which is n plus 1 over n. So what is the limit of an as n goes to infinity? That will be the limit of n plus 1 over n, and that will be 1. Yeah, 52. Yeah. I have what? a1 is 1 over 2 times 3. a2 is 2 over 3 times 4. a3 is 3 over 4 minus 5. So an will be what? Will be n over n plus 1 times n plus 2. Yeah. So this is the limit as n goes to infinity of an. That will be the limit as n goes to infinity, n over n plus 1. This is not the same degree. So degree of the numerator is less than degree of the denominator, and that will be 0. So I hope this is a good review for finding the limit. And I link it with finding the limit for the sequence. I know most of the problems I did it in the previous video, but I said this video just to concentrate, to link it, to make a review about what we did about finding the limits in general, what we did in Math 101. I link it with the sequences. I hope this video also will help to understand the topic. Now, what is remaining is about the factorial and about monotonic and decreasing monotonic, and also about bounded sequences. I'll try to explain hopefully in the next video. Thank you. I'll stop the recording. I think that's all for this video. Yeah, it's a little bit lengthy one. Stop recording. Thank you.